Hi, Fabio from Hopsworks here, and today we're going to be taking a look at how to generate training data from features stored on the Hopsworks feature store. So if you have seen the previous video, we are taking a look at the how to create a feature view. A feature view, as we said, is a container for the features that a specific model needs, right? So it's a selection of the features potentially from different feature groups, join them together in a point-in-time correct join that can be used to generate training data, that can be used to generate inference data for real-time inference or batch inference, right? So in this video, we're going to be taking a look specifically at how to generate training data to train a specific model. And we're going to be taking a look at how to do that using the Hopsworks API and the different APIs you can use to generate training data depending on the use case you're working with. So if you go to Hopsworks, we can have a look at what we have set up so far. So we have this fraud model feature view. Here you can see all the features that we have set up. They are from different feature groups. Some of these some what we call model-dependent transformations. In this case, we use the label encoder. This can also be normalizations like min-max scaler or something similar, right? We are also, and this is going to be important in a second, we have also marked one of the features to be actually my target feature, which is what we are trying to predict, which is what the model is trying to predict essentially. So if we look at how we generate training data, we have different APIs depending a little bit on what we want to achieve, right? So as always, the first thing we have to do is importing the Hopsworks library and calling the login method to be able to connect to the Hopsworks feature store. The second thing is we need to retrieve this feature view object from the feature store. This is what is going to give access to which features we need in our model, and it's going to give access to the API to be able to actually create training data itself, the training data. So in this specific case, we are working with transaction data that have a specific times and timestamps, right? So what we want to do when we train a model, we want to train the model on a time range of data, right? So a couple of months of data. And we want to test the model over maybe the last couple of weeks of data, just to make sure that like the patterns that the model is identifying as fraud are actually still present in my data set, and just make sure that like the model itself works properly. So the first thing we're going to do here is call this train test split. Here we are specifying basically the ranges for when my training data starts and ends, and when my test data starts and ends, right? This is going to give me back 4 different pandas data frames, 2 pandas data frames with our like features as called, and the other 2 data frames with the labels, right? We have one pandas data set with the features for training and 1 for testing, and then we have 1 pandas data frame for the labels for training and the labels for testing, right? This is going to be returned on the fly. The data here is not snapshot anywhere, so it's just going to be existing memory within the context of a pandas data frame. And we can have a look at it. We can see the X train and Y train, how they look like. One thing I want to point out is the category and the country, for instance, right? So if you look at if I go back and look at the feature data itself, so in the feature store, I can have a look at the transaction data, for instance, and I can have a look at the online data for a second. Like you can see the category here is actually text, right? That has been encoded by the label encoder attached to that feature in the feature view, so that now you get basically numbers 0, 1, 2, depending on the category here. And something similar happened on the country. So the feature view and the Hopsworks API have applied the label encoder and the label encoder transformation behind the scene for you, so you don't have to worry about it essentially. So as I said, if you call this train test split method, the data exists only within the context of a pandas data frame, so exists in memory. You can also materialize that train data with a slightly different method called create train test split. The idea behind this is the same. You specify when the train and the test split start and end. Here you also need to specify the data format you want to persist your training data in. In this case, we are choosing CSV, but for instance, if you're building a TensorFlow models, you could be using TF records. You can specify how many files you want at the end, and some statistical configurations, right? So what's going to happen if you call this method is that that job is going to be kicked off in the background to materialize this training data set, either on OpsFS or somewhere else like on GCS, S3, or ADLS. So somewhere where you can actually read it multiple times without recomputing the same training data set every time. If you want to get access to it, right, what you can do is use this get training test split method. Here you're basically accessing training data that have been materialized, right? So in this case, you need to specify which version you want to access. And as always, you get back the different pandas data frames to be able to train and test your model, essentially. So splitting by time, it's one of the functionality the Hopsworks provides, and the other functionality the Hopsworks provides is actually splitting by just randomly, essentially, right? So this is what happens on this specific example, where we are looking at creating, in this case, 3 different data sets. Where like we're creating a test, a validation, and a train data set, and we are not specifying start and end times in this case, but we are specifying the amount of data we want on each of the different splits, essentially. So in this case, we want to say we store 30% of the data set in the validation, 30% on the test, and everything else stays on the train split, right? So in this case, the splitting happens randomly. You can specify, you have options to specify, for instance, the seed, so you can reproduce a training data set in the future. It's not shown here, but that's an option you can find in the documentation. You can also have the description, and the description is going to be useful if you start having a lot of train data sets for a specific feature view. You can actually see them in the UI. So if you go in your feature view right now, you can see that we have a lot of different train data sets in the feature view itself, and so we want to make sure that we know which one it's for which purpose, essentially, and so the description helps with that. One more thing I want to show you is you can actually, when you create a training data set, you can actually add additional filters to the training data set itself. So this is useful if you have situations when you have the same model with the same architecture, the same input features, but you want to train a model for, let's say, the US customers and like the EU customers, for instance. What you can do with the Hopsworks API, you can create a single feature view selecting all the features, and then you can create 2 different training data sets for the US customers and for the EU customers, right? The way you will do that is by specifying this extra filter, right? This extra filter will be applied on top of the filters that you already specified in the query itself when you created the feature view, and will only be relevant for this specific training data sets, right? So in this case, we created 2 different ones, one for the US customers and one for the EU customers. And we're basically using the same APIs that we were looking at before, so with the train test split that we discussed earlier. One more thing is you don't have to use the APIs to actually create a train data set. You can do that from the UI itself. I can quickly show you. If you go in the feature view overview page on Hopsworks, you can see there is a new train data button here. If you click it, what's going to happen is that it's going to prompt you like a form where you can put the description. So let's test description. You can specify the start and end time for your training data. You can specify where to store it, either on Hopsworks itself, or as I said, it can be stored outside using the storage connector to, let's say, S3 or like GCS or ADLS. You can specify a data format. CSV is one option, TF record is another one, Parquet is another one, and there are a bunch more that Hopsworks supports. And you can also specify the type of splitting you want, as we discussed, either random splitting or time series split. So I can click, I can select random at the moment. I can say 70% goes in my training data split, and maybe 30% goes into my test split. And then basically what's going to happen is that I can keep going, and this is going to kick off a job to actually create this data set for me and materialize it on Hopsworks so I can use it to train my model, right? So these are all the APIs you can use to create training data and train your model. We're going to be looking at in the next couple of videos how to actually do the same, but for inference data, for batch inference and real-time inference. So I'll see you in those videos.